I shared the screen where you saw, let me continue sharing the screen or reshare the screen where you saw that there is assignment 3 is up. But this time you're going to have 2 weeks, so there is some breathing room for this. Originally, I made a mistake and I put 12th here. And luckily, there's always people who notice initial mistakes. I'm very grateful for that. So there are a couple of things that I fixed. So please do re-download this assignment. First of all, the deadline is corrected to what's in your course outline. Basically, it's in 2 weeks, Monday, 8 a.m. There are a couple of other small things, and I will fix something else. Somebody noticed some inconsistency with my naming of this function, I think. There is a plural here. Somebody was saying there's plural here and not, I don't see it, but I didn't have time to look at it. I may fix the name of this function. Let's continue with the material we did last time. So here's what we've seen first. We've seen our first loops. We have seen this particular form. That was this thing here. So let's recall the form before we start using it again. The form of the loop is that you have 2 keywords, for and in. After in, you have to have some sequence. This is the sequence over which element you want to loop. So if it's a string, it's a sequence of characters. So you want to loop over the characters. You want to be taking characters of a string one by one. And each time you take a next character, you want to execute the loop. You enter the loop and execute the loop. Okay, so here you put a sequence. In our case, it's a string, apple. Okay, between for and in, you need to put a variable name. Okay, that's going to be a variable that will be created the first time you encounter the for loop. So this variable, and then on purpose, I chose blah, not that you should be using name like this, just to demonstrate you can really name it like anything. Okay, so this variable gets created first time you encounter the loop, right? And the first elements, so the first time you encounter the loop, the first element from the sequence gets placed in this variable, okay? In other words, what gets executed is blah is equal to first element of our sequence. In our case, it's a lowercase a. So what gets executed is blah is equal a, like a string a. So that creates a variable blah. Then you enter the loop, you print blah, which is an a for an apple, and then some stars. When you come here, this is a block. The indented block after for is a block that belongs to for loop. What does that mean? That's a block of code that will be executed every time you enter the loop. That's the block of code that you will be repeating, okay, that you want repeated in your solution. Okay, so when you come to the end of that block, Python and other languages, they always go back to the beginning of the loop. That's why it's called looping. You always go back to the beginning of the loop and you take the next element of the sequence and you place it in blah. In other words, what gets executed is blah is equal P in this case. You enter the loop and so on until you come to the last element of the sequence. In that point, Python realized there's no more letters to assign to a variable blah, so I'm leaving the for loop. What does that mean, leaving? Well, it means I'm going to execute something that comes after, if there is anything after. Okay, so we get, let's run this. Okay, so that's what gets executed. All right. So in addition to this, first explanation of loop, we solved a little problem that says write a function that if you give me a string, that string stored in a variable phrase, in a parameter phrase, what I want to do, what I want function to do is to print all the vowels in that phrase, in that string, okay? So the solution was that you go through the elements of the string one by one, you test if it's a vowel, if it is, you print that character, otherwise you go back to the beginning of the for loop and take a next character. Okay, so let's run this and see what did we have. for example, if we had August, it would print all the vowels in the word, which is capital A, then U, and then goodbye. Well, I guess I can remove this goodbye, but that is not important. Okay, so let's now see similar problems related to this, where you're going to see some classical algorithms in, let's say, computer science. They're so simple and so common that you may not even think of them being called algorithms. I guess everything is an algorithm. It's a solution to a computational problem, but yeah, let's get to the problem. So I want to solve a very similar problem, but instead of printing every vowel, what I want is to count them. So what do I want? Let's understand that. What I want is that I want my function to return number of vowels in this given phrase. So phrase will contain a string, and I want to return the number of vowels in the phrase. Okay, so let's think of the examples. By the way, the example runs, you can put them in docstrings. And in future tests and things, I may sometimes give you test examples in the docstrings. But one of the advantages of having a test examples in the docstrings is that actually there's a way to automatically test your function, that Python allows you to automatically test your function by running those example runs that you put in the docstrings. But you can read about it, how to do this, to do these example runs from docstring, use them for automated testing. All right, so how do I want my function to behave? What I want is, if I call it, for example, let's use the same example. I want the function, in this case, to return 3, because the phrase or string August has 3 vowels. Okay. In case of something like, I don't know, the function, it has no vowels, so it should return 0. So here we have 2 example runs that help you with understanding of how the function works. Okay. By the way, that reminds me, you should always, hopefully you already realize this, when you're explaining what a program should do or what a function should do, you have to be extremely precise. You can use vague language. Using a very precise mathematical language can be difficult to read. So after reading, immediately going to the example is going to greatly enhance your understanding of what you need to do. So for the same reason, actually, it's helpful to have examples, even part of a docstring, and you can also use it for automated testing of your functions. Okay, let's do the type contract. Phrase, we said, is a string. It's just going to be text where you want to count the number of vowels. And what do we return here? By the way, in a print vowels function, notice that the function doesn't return anything. So the return type is none. Okay, there is no return statement. This is something that many students still are struggling with. This one, it is required to return something. Let's read what it says. The function returns the number of vowels in, I guess I need in a phrase, or in phrase. Phrase is the name of this variable. Okay, so what does it return? When you're counting something, the only meaningful answer is an integer, right? When you count, you say there's 0 things, 1, 2, and so on. So what we are promising to return if somebody gives us a string is an integer. There's no preconditions, we take any strings. Okay, so let's see how to solve this. So again, always imagine you're doing this on a paper, that computers don't exist, somebody give you a ginormous text, and you have to go through it and count a number of vowels. Why am I always saying ginormous text? Is because with the ginormous text, you have to come up with some procedure. But that's what algorithms solution are. You have to come up with some consistent procedure. If the text is very short, like 5 words, we humans can eyeball these things, right? So imagine I give you a text with, I don't know, 1,000 characters, and you have to count the vowels. So how would you do it? Everybody would do the same thing, I guess. You look at the first character. If it's a vowel, you say, okay, I found one. Look at the next character, or you would write down one. And look at the next character. Is it a vowel? No, I move to the next character. Is it a vowel? Yes, I increase my count to 2. Look at the next character. Is it a vowel? Yes, I increase my count to 3. Okay, so in this case, my hands are keeping count. They're like a variable. They keep track. I even, in example like this, you need a variable. I need to keep track how many did I find so far. So we're going to need a variable to keep track how many we found so far. And in our procedure, we need to look at characters one by one. And for each, we take a character, we test if it's a vowel. If it is, I increase the counter. Otherwise, I take the next character. Okay, so let's code that. So the first thing said, I look at characters one by one. Whenever you hear this, you should use loop, okay? Again, to demonstrate that you are picking a variable name, I'm going to pick not very informative name. I'm going to say X. Then in what do I want to loop? You ask yourself what sequence I want to loop over. And then I'm going to say phrase. I want to go through the elements of the string that is stored in phrase. And the variable that is going to contain these elements one by one, I'm going to call it X. Okay. So first time I encounter the loop, let's say it was this example. The way loops work, we learned is that Python is going to take the first character, which is A, and it's going to do X is equal to A, and it's going to enter the loop. So right now here, inside of the loop, where the cursor is, X is a capital A. So for each character, I have to test, is what is stored in variable X, is the current character I'm looking at. So is what is stored in X, is it a vowel? We already learned how to do that in last class. Okay, and here if it is, so when we are here, it means X is a vowel. If we get true. Okay, so what did we say we need to do? We need to increase our count, right? In my case, I was doing that by lifting one more finger. Okay, so in math, you just add 1 to whatever variable you had. But I didn't even create that variable. So I better create the variable first. I should create it before I even get to the for loop. Let me give at least that variable a meaningful name. I'm going to call this variable counter. Remember in Python, to create a variable, you have to assign value to it. So what is the most natural thing to assign to variable counter? So what did we start with here? You start with 0. Before you start even looking at a string, how many vowels did you find? 0. Before we even look at any character, before the loop, before going through the strings, you didn't find any characters, right? So I should initialize my counter at the beginning to 0 because I haven't found anything yet. And in fact, if I don't find any vowel, what is stored in counter is the correct answer. You just return counter, you found 0 vowels. Okay, so if X is a vowel, then I need to increase this counter. So here's how you do it. You just add 1, right? You know how to do this. You add 1 to the counter. But now you should also remember that you did that. So you have to change what is stored in the counter. Okay, so first you add 1 to the counter, and then you store that value into the counter. All right, so for example, in the case of August, we're going to counter will be 0 first, but when in this line, we're going to have if letter A is in one of these and it's true. Therefore, we're going to execute this. That's going to be 0 plus 1, that's 1. You assign 1 to the counter. So then from then on, counter is 1 until we found another vowel. Okay. And else, there's nothing to do, right? We don't need to do anything if it's not a vowel. Well, then I might as well remove this. Okay. So, and then we go back to the beginning of the loop and the next character is stored in X. Once we are outside of the loop, right? So when you're outside of the loop, so the code line up with 4, outside when the loop finishes working, that means we went through all the characters and we increased the counter every time when we encountered a vowel. Well, that means that at the end, what is stored as counter is the value that we are interested in. It's the number of vowels that we encounter. So we are done. Okay, so let's run this to at least see that it's working. Okay. All right, so here it is. Okay, let's see this. It's working for this. Let's say if we don't have any vowels, we get a 0. Okay, so let's look at this solution. Let's look at this. This is the classical solution that I was talking about. For those of you who programmed before, this becomes a second nature, this type of, this you encounter so much that this type of variable, so you notice that this variable counter is just keeping track. It's counting something. What is it keeping track of? It's accumulating actually how many vowels you found. Every time you found one, it adds another one, okay? This type of solution is so common that this variable, the variable that plays a role of keeping track, even has a name. It's called accumulator variable. So what are we accumulating in this particular case? It's accumulating ones, okay? What do I mean by that? In general, you should think of every variable as a bucket, because actually they are in your memory. There are memory cells where the values are stored. So think of a variable as a bucket which stores some value. So at the beginning, this bucket has number 0. And then every time you encounter a value, a vowel in this case, we drop a 1 in there and the value is 1. Next time I drop a 1, the value is 2. So this variable is accumulating ones, if you like. Okay, but that is more for visualization purposes. What it does is just a counter that you variable that you use to keep track of the solution. By the way, this is so common, this type of solution, that not only the variable that performs these functions are called accumulator variables, there is even a shortcut for this operation. This happens so much that there is a shortcut for it. In other programming languages, there is a shortcut. If you want to just increase what is in some variable by 1, you can do variable name plus plus. I really like this one. I used to use it all the time. But this one doesn't exist in Python. The plus plus doesn't exist in Python. But this shortcut exists, which is, I believe you first have a plus and then equal, then 1. Okay, so what does this mean? This is a shortcut. So basically this expression here and this expression here are identical. Okay, this says basically it's a shortcut, add to counter 1. If this expression here you were adding 10, the shortcut would be this. This means to the counter, every time you execute this line, add 10 to the counter. Okay, you can use these shortcuts if you like. As I said, this type of solution you're going to be encountering all the time, both in this course and in your career if you end up doing computer science. So you can choose to use this shortcut. As I said, I used to use this plus plus all the time. This one I don't use. First of all, because I'm basically, for teaching purposes, I find this more readable. But the main reason I don't use it in my personal work, let's say, is that I keep on forgetting, is this shortcut plus equal or equal plus? I think it's plus equal. Okay, but you can use it. It's up to you, students, right? But in the course, I will be using plus. I will be using the full expression and not a shortcut. Okay, so that's the solution. This is how you count anything, not just vowels and so on. Okay, so here's a different, by the way, in your assignment number 3, you will encounter lots of problems, in part 2 in particular, where you will have to do something similar to this. Okay, either you're going to be creating some summation, so you're going to have accumulator variable where you're adding whatever sum requires you to add. Or you will be creating new strings, which is what we're going to be seeing in the next example. By the way, this reminds me, there was already a question on the forum about Pell numbers. You should use accumulator variables, because students who are familiar with recursion, your solution is going to crash on big enough integers. Those who find closed formula, your solution is going to crash. And in recursive solution, the reason it crashes is to understand why it crashes, you have to understand height of recursion, and in addition to understanding how stacks work in programming languages. And we're going to get to that only at the end of the semester. So your solution is not going to work for all the integers if you use recursion. If you're using closed formula that you can find on Wikipedia, because it has square roots and division, you're going to be creating floats. And remember, floating numbers in Python and all other programming languages, you cannot have arbitrary big numbers. So it's going to crash when your input is a big integer, not even that big. If you give something over 1,000, both recursive solution and closed formula solution are going to crash. So you'll have to think and use something like this, accumulator variables, and create your own summation and use only integers, because in Python, integers can be arbitrarily big. That means that you will be able to handle arbitrarily big integers. Okay. So this is one type of a solution, one type of solution that you will have to design. And here's another one. So let's say, oh, wait a minute, actually, I don't, in addition to discount vowels, I want to have a different function. I want a function that basically returns only the vowels, so that creates a new string. So here's what I want. I want a function that you give me a phrase, you give me a string. I want to create and return new string, but that new string is going to have only the vowels from the given string. Okay, so let's again, things are easier to understand on example. So let's do first an example. All right, so instead of count vowels, we are now going to do, I want you to give me only vowels. So in this case, what did we say? The function should return a string. Okay, so I start with a single quote or double quote to indicate that function is returning a string. If the function was printing, there would not be quote here. If the function just said the function should print all the vowels that it found, end of the story, then you wouldn't have it, because remember that print is made for the users, meant to be user-friendly. It removes the programming language indicators such as quotes when it prints strings. Okay, so this function should return a string, and that string should contain all the vowels in the given phrase. So in this case, in a given string, in this case, A is a vowel, U is a vowel, G is not, U is, S is not, and T is not. So the function returns this. It returns a string that contains all the vowels from this given string. Okay, let's take another example. Okay, so before I take another example, actually, let me do a type contract. So let's say, and after one example, we should be able to write type contract and the description. So again, input is a string. Now, what do we return? So let me write a description. We are returning a string. So this function should return a string containing all the vowels from the given phrase. Okay, so what does the function return? That is a string. All right, so for each input parameter, you tell a user what you expect. I have only one input parameter and I'm expecting strings. If you give me a string, I'm going to return a string. Okay, and here's a description. All right, let's do another example here. So what if I had, what was it here? So when we were counting, it was obvious here that in this example, you just return a 0. So what should my function return now? So let's understand, what do we want this function to do? You give me a string and you return a string. So the function should create a new string and return that string. And that string should contain all the vowels from the given string. Okay. So we are supposed to return a string. If there is no vowels, it should be a string with nothing, with no elements in, with no characters in there. So this is what we are returning. This is an empty string. Okay. So don't mix this with double quotes. This is one apostrophe and then another apostrophe. Okay. So this is immediately without a space. This is an empty string. We saw this when we were learning about strings. Okay. And it makes sense, right? You're supposed to return a string, contains all the vowels, right? So you're returning a string without anything because you didn't have any vowels in this example. Okay, so how would you do it? Again, on the paper, you have a 1,000-line string and I have to write down all the vowels. What's the procedure? What's the algorithm? I look at the characters of a string one by one. And every time I look at a character, if it's a vowel, I write it down. Okay, I add it to my current list of vowels. If it's not, I move to the next character. If it's a vowel, I add it to my current list or current sequence of characters, the current sequence of vowels. If it's not, I move on. All right, so let's do the same thing. So the beginning is exactly the same, right? Our solution says I go through the elements or characters of a string one by one. So therefore I need a loop. Again, to demonstrate that you can give it any name, I'm going to change it to Y. All right. So again, once I enter the loop, I need to test, is the character that is stored in Y, is it a vowel? Okay, we have seen already in the last lecture how to do it, and this lecture again. All right, so if it is a vowel, what do I want to do? I somehow need to keep track. I somehow need to be storing all the vowels. What are vowels? They are characters. So what do you use to keep track of all the vowels, of the characters? How do you put characters together? Well, that's a string. Okay, so I need to be adding characters to a string. So I need to have some variable to keep track of the current string that I'm building. I'm building a new string. So I should call this new string, I'm going to call it vowels. I'm going to give it meaningful name, unlike my Y variable here. So remember, in Python, to create a variable, you need to assign something to it. So what should I, what's a reasonable thing to assign to this? Not only reasonable, you should ask yourself, what is the correct answer if I don't find anything in the for loop? Okay, what happens before I even look at any character? How many vowels did I find before I even look at this? Because it's the for loop that will be processing my string. What should be the answer? It's an empty string, okay? At the beginning, I didn't find any characters to add to my vowels, so I start with an empty string. It's kind of equivalent to when you're counting to 0. And again, this you will have to do in many of the questions in your assignment number 3. You will basically be asked, or given a string, scramble it. Well, scramble, meaning let's pretend we are doing cryptography, right? I give you a string, now you reverse it, then after every second element, add some letter and stuff like this. So that means as an input, you're going to have a string, and then you're going to have to create a new string where the order is different, where you added some extra stuff and so on. Okay, so you always start with an empty string when you're building a string. All right, so here, once I find a vowel is a character, okay? I wanna add it to, I wanna glue it to my current string, okay? So vowels is a string. At the end of my current vowels, I wanna glue to it a vowel that I found. So what is stored in vowels in the string, what is stored in Y is a string as well, because remember, Y is just a variable that takes characters from this phrase one by one. So what is stored in Y is a character. So here we have a string and a string. So plus is going to do concatenation. It's going to glue these two. It's going to glue my current vowels with the new vowel that we just found. And of course, you need to remember that by storing the new string into the vowels. Okay, so what do we do if it's not? If Y is not a vowel, there's nothing to do, right? So you might as well remove this part. Once we are outside of the for loop, in other words, once the for loop processes all the characters one by one, then what is stored in vowels is basically all the vowels that we found. In a variable vowels, it's all the characters that are actually vowels. So we return that because that's what we promised to return. Okay, so let's see if that works. All right. Let's run these example runs that we already have ready. Okay, so that's working. It returned all the vowels from that phrase. And let's see this one. It's not, this one doesn't find any vowels and returns an empty string. By the way, here too, you can use that shortcut if you want. It would be the equivalent to this is vowels. You want to be adding Y every. So this basically is just a shortcut. This and this is identical. Don't let this confuse you. It's really just identical thing. So if you, it saves you spelling vowels twice. That's all it is. Okay. All right. So that's what I wanted to show. So again, both of these things are really super classical, simple solutions that have to become to you a second nature. That's how common they are. They appear everywhere. And I'm sure any of you students who program for any reasonable length of time, this becomes such a natural thing to do, okay? All right, and again, in your assignment, you will have to do these type of things where you're starting with an empty string and then building a new string, or you will have to compute some sort of summation or something where you have to accumulate and be adding values. Okay, so now, in addition to solving these problems, let's now really make sure that we understand how they work very quickly. So, oh, what did I do? Let's look at this one. All right, edit. I'm gonna erase this. So and what do we do? Count. All right, so here we have our function. I want to call the function on a simpler example. I don't want to do August. Let's do something like A, B, A. This is going to make a call to this, but I want to actually print the results. And remember, if you're actually in a file and this is equivalent to a file, you need to print what function returns if you want it displayed. So let's visualize execution to understand how this solution actually works. So as always, Python starts in line 1 or the first command that is lined up with the leftmost edge. You should always ask yourself, and I already showed you this, so hopefully you will know the answer to a question, where does the red line move next? So Python executes this, learns that function count vowel exists. Hopefully you didn't say 3 because the body of a function is not executed until you encounter a function call, and this is a function definition, not a function call. So basically the next line, the red thing is going to, arrow is going to jump to line 10 because that's the next line of the code. This thing here is just a comment. I'm just indicating for myself, this is my main part. So Python learned that this function exists. So let's see what we have here. It says print, and then you have open parentheses. But inside of this parenthesis, we have a function call. So obviously, this function call has to be executed first before print function knows what to print. Okay, it's going to print whatever this function returns. So this function starts running, so the red line moves back to 1 at the beginning of the function. Okay, so the main, so global frame is going to pause, and this function starts running. You can see we got a new box, function count vowels running. The first thing that gets executed is you look at your parameters, that's a phrase. So variable phrase is assigned whatever is sent in this function call. So whether you want it or not, phrase is equal string ABBA gets executed. That creates the variable phrase, as you can see here, and what's stored in there is that string. Now, because we had the function call, the body of the function will actually be executed. So the Python moves to line 3. This creates a variable counter that stores 0. And now there was some confusion among the students how for loops work. Hopefully explanation today clarified, but let's see it again. What's stored in phrase is 3 letters, ABA. First time you encounter a for loop, here now comes the use for this variable X that we named here. What gets executed, whether you want or not, is X is equal first element of the sequence, first element of the string. So what gets executed is X is equal to A. So therefore that creates a variable X where the first letter is stored. Then you enter the loop, you test, is it a vowel? It is. And now, because it is, on the right-hand side, a counter, what is currently counter is 0, is we're going to execute 0 plus 1, that's a 1, and it's going to be assigned back to counter. So after this line is executed, you will see that counter goes back to 1. There, actually, we had at the end of the for loop, so as always, that's why we call loops. At the end of the for loop, you go back to the beginning of the for loop. That's line 4. Python now execute X is equal next character of the phrase. So X is equal B gets executed. So you're going to see that this letter X gets changed to B. We test is what is stored in X the vowel. It's not. So it goes back to the beginning of the for loop. What gets executed is X is equal the next character in the string. Next one is lowercase a. And you see here that X gets changed to lowercase a. We test, is it a vowel? It is. The counter gets increased. 1 gets added to the counter. Python returns to the beginning of the for loop, tries to take another character and realize I'm at the end of the string. And now I'm actually leaving the for loop. So then where is the red line going to move next? Answer for yourself. So I'm leaving the loop. So the next line is actually this, what is lined up with 4, with F, which is this return statement. So it's going to return whatever is stored in the counter. What's stored in the counter is 2. So this function, this blue function that was running here, is going to disappear. It's going to terminate and leave in the air, if you want, value 2, or it's going to return it to this main. Okay, so this one, and main was waiting. So the global frame or main, the same thing, was waiting over here. So this thing is going to be replaced by what that function returned, which is a 2. So you see that function disappeared. 2 was sent over there. So we actually execute print 2, and you see Python executed it. Okay, so that's how it works. I did that one in more details. This one I will do super quickly, and then we're going to move to a next topic. Okay, so here, all right, so this one, I'm going to remove these comments, and in the main, I'm going to make a call only vowels. Let's do the same example, and I want to print whatever the function returns. All right, so we execute that. All right, so now hopefully you know it goes straight from 1 to 12 in this case. We have a function call to only vowels, so therefore the main has to pause and function only vowels starts. Phrase is equal ABBA gets executed. We enter and the body. This creates a string that stores an empty loop. This creates a variable Y and assigns capital A to it. We test if it's a vowel, it is. So now this is going to be executed. What first right-hand side, what is vowels? Empty string. So concatenate to empty string whatever is stored in Y. What's stored in Y is a capital A. So we're going to do concatenation of an empty string and a capital A string that creates a string A, and it stores it back to vowels. So you see now vowels contains a letter A. So now Y takes the next character, it's a B, but that's not a vowel, there's nothing to do. Takes the next character, is lowercase a, that is a vowel. Now we execute this. What is this? This is vowels, is currently capital A, Y is lowercase a. We need to concatenate them. We do and put it back to vowels. Therefore, what is there is capital A. Back to the for loop, realize that's over. Loop is over, we go back to return. What gets returned is that string. The function terminates and returns that string over there. So A is returned here, and print function is told to print A, and it does. Okay, so that's how it works. Okay. So that those are my example about looping over strings. But I'll show you different now. I'm going to move to another super common form of looping. It's still for loops. Okay, so it's still for loops. Remember, actually, remember when I was telling you this format. So here, a for variable name, then in, then a sequence. Okay, instead of all the time saying a string, I was saying a sequence. Why? Because this same format works no matter what the sequence are. So what's another types of sequences? So strings are sequences, a sequence of characters, where there is a first character, second character, and so on. What are another natural sequences? Sequences of numbers are probably even more natural. Here's a sequence, 1, 2, 3, 4, 5. You know, see, when you're counting, you get a sequence of number. Okay, so you can use this type of syntax, this type of for loop, and it works exactly the same way, no matter what the sequence is. Next class, we're going to learn about lists. I can even show you straight away. Here's a list, 2, 10, minus 5.4. Okay, so here's a list that contains 3 elements, and a loop like this works exactly the same. I can say for X in what sequence? Well, this sequence, list is a sequence. I can say print elements of the list one by one and print some stars in between just to make it look similar to those strings that we did. Okay, so run. There you go. It prints the elements of a list one by one. Okay, so the format is for variable name in and then any sequence. So far we've seen strings and now first time lists. But here's a function in Python that produces some of the most natural sequences that you are going to be needing and using all the time. Okay, so let me show you slides for it. So there is a function in Python called range. For now, forget about the loops. Let's understand what this function range does. The simplest way to think of it, although it's not exactly true, is that it produces a sequence of numbers. It does produce a sequence of numbers, but on the fly, but it doesn't matter for now what that means, okay? So here, it's the easiest to think of an example. If you call this function with range 10, for example, it's going to produce a sequence of 10 numbers. And those numbers are, if you ask us humans, give me the most natural sequence of 10 numbers, you're probably going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You're going to start with 1. However, again, computers don't start at 1. So if you do range 10, it's going to produce a sequence starting at 0, going up to 10. So if you do range 10, it's producing a sequence 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So up to 10, not including 10. Okay, so more generally, if you call range n for any integer n, It's going to start at 1 and produce a sequence 0, 1, 2, all the way up to n. So that means the last number it produces is n minus 1. That's one form. So this range function can produce various type of sequences. So for this one, if you do, for example, range 10, if you just give it to one integer, it has a limitation that always starts with 0. But maybe I don't want to start with 0. Maybe I really want a human sequence, right? 1 to 10, for example, just inventing. You can start at 5, right? You may, for whatever reason, want to start at any number. In that case, you use this form of range function. You give it 2 integers. Okay, the first one is the number. So by the way, these 3 forms are very similar to slicing in terms of where do you start, where do you end? Slicing that we have seen last class. Okay, by the way, in your assignment, in addition to these accumulator variables on strings and kind of and additions, you have to think of slicing. Otherwise, some of these will be way too difficult, right? Slicing is going to be your friend. Think how slicing can help. All right, so range function with one number, given one number, it produces a sequence from 0 up to that number. If you give it 2 number, produces a sequence starting with the first number, going up to the second number. So if I do range, then 1, 11, that means starts at 1, go up to 11, and not including 11. That means it's going to produce 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So that's the form with 2 numbers. First number is where you start at exactly, and the last number is up to. And the third form is the one where, okay, you may say, well, all of these sequences are just really consecutive numbers. What if I want every second number or every third number? What if I want a sequence of the form 1, 4, 7, 10? I want them to jump by 3. Then you use the third form, okay, which the first number, again, is where the number where you start the sequence. The second number is up to what number you go. And the third number is by how much you jump. What do you add, okay? The default, again, is 1. So if you omit that, that means that the next number is in a sequence is always 1 larger than the previous one. So let's see example, if you do range 1, 10, 3. So we started 1, go up to 10 in steps of 3. So 1, 4, 7, I'm about to do 10, but it's up to 10. So range 1, 10, 3 produces a sequence 1, 4, 7. Okay, so 3 forms. Hopefully they're natural. Hopefully they are natural to you. At least they shouldn't be unfamiliar because you've seen slicing and the meaning of these numbers is the same. Okay, so let's see why is this useful. Let's see how to use this range function. Okay, so forget this. Let's look at something like, I remember all the time, often I was showing an example on this silly function, draw square, just prints a trivial draws an ASCII square, if you like. Okay. All right. So you have seen this. And let's say, of course, if I made a function, hopefully I made it because I need it for something, or I'm just playing with something. So then I want to use it. So in the main, I call this function. I run it. And there you go. It draws a rectangle. Well, then you will say, actually, I want 2 rectangles. Okay. How do you draw 2 rectangles? Well, I do this one and I call it again. Maybe I want some space between them. So I'm going to add some remember this, print without any arguments, prints a new line. So this should draw through 2 rectangles. Let's see if it does. Oh, there you go, draws 2 rectangles. What if I want to do 3 rectangles? Well, I call a function again. There you go, it draws 3 rectangles. Okay. What if I want 100,000 rectangles? Well, hopefully you're not going to copy paste this line 100,000 times, right? This is what loops are for. And so let's try to use this range function loops to draw 100,000 rectangles. Okay, so what do I want? Let me show you first. I'm going to give a variable name I in range. Let's start with 100, not with 100,000. All right, and let's start with 10 and then understand why does this repeat this? Why does this type of loop repeat this call 10 times? Or why does it draw 10 rectangles? First of all, let's see that it really draws 10 rectangles. This Python shell is kind of slow. Printing is slow. And it's really due to idle. I'll show you in a different terminal that it can print this lightning fast, but they're just on a side comment. Okay, why does this execute the body of the loop 10 times? All right, so remember how loops work. You for variable in sequence. So what is this sequence? So this sequence here, range produces 0, 1, 2, 3, 8, 9. That's the sequence that this guy produces. And how do for loops work? They work by saying, I'm going to, first time I encounter the loop, I'm going to create this variable I, and I'm going to assign the first element of the sequence to I. So I0, you enter the loop and you call, execute the body of the loop. What's in the body of this loop is just a call to draw a function. So first time you enter the loop, I0, and you call draw function and it draws a rectangle. Okay, you are here at the end, just to see that you at the end of the, let me put something outside of the loop. So here we're at the end of the for loop. You always go back to the beginning of the for loop. What does for loop do? It's assigned now I is equal, what is the next in the sequence? I is equal to 1, and then it enters the loop. It enters the loop. What do I have to do in the loop? Oh, draw a square, draws a second square. Then it goes back to the beginning of the for loop. Is execute I is equal to what? Oh, I is equal to 2 now. Enters the loop, executes what it says. What does it say? Oh, draw a square, and so on. So how many times do we enter the loop? Well, we enter the loop as many times as we have elements or numbers in the sequence. There's 10 numbers, so we're going to enter the loop 10 times. That means 10 times we are going to call draw a square, and it's going to draw 10 squares. Okay, so we have seen that. I can try 100, but already 100, it would take, the printing in idle, as I said, is very slow, but this gives me an excuse to show you how else you can run Python. You run it basically directly in a terminal. So you open a terminal in a Mac, you just go in a Spotlight and put terminal, okay, and it starts this. And okay, and then it opens a window like this. Let me show this more. All right, so it opens a window like this, and normally it opens it in your home directory. So I'm going to show you that. Okay, print working. So this is basically a way to communicate with the operating system. You all grew up with operating system where you can click on things, but it used to be that you work in a terminal and you are communicating with the operating system through a set of commands. And this one tells you which currently folder you're in. You have to navigate to the folder where your code is with the command cd, change directory. Okay, so my program is in this. You see on the top here, lecture 8/b.py. So that's the one I want to execute, that program. So you just type Python and then the name of the file that you want to execute, name of the program that you want to execute. I press enter. You see, it's so fast that we didn't even see it drawing things, but in fact, it drew 100 rectangles. So yeah, go back, I'll scroll back and back. If I put 1,000, it would be the same. Okay, 1,000. All right, let's run it again. You see, I'm going to press enter and it's done. It's already done. We had goodbye, right? So the terminal is way faster than idle if you're running things directly in terminal. Okay. So actually, this is a good moment because there's often discussion about efficient, you know, what does it mean to have, I already mentioned, what does it mean for a program to be efficient? Let me stress that it's not about the number of lines of code. It has nothing to do with the number of lines of code. Efficiency is how fast your solution is, in particular, how many operations does it do? And lines of code, if you don't have loops, and if you know recursion are a form of loop, if you don't have loops, every program known to man is efficient. Without loops, every line of your program is executed exactly once. Okay, so how many lines of code can you write in your lifetime? Let's say 1,000,000 lines of code you can write in your lifetime. If you take a program and every line, so it doesn't have a loop, so you're not repeating the same line. If you take a program and you don't have loops and you spend your lifetime writing this program, any computer, even the one you're sitting on, isn't going to execute it in a second. So every one of them is efficient. Everybody is willing to wait a second. 100,000 lines of code, so 100,000 operations, sorry, 1,000,000 operations, most of these computers can do in 1 second. What is expensive is loops, okay? So first of all, I was explaining to you why does this piece of code, why does it draw 1,000 rectangles? First of all, you need to understand that, because otherwise how are you going to solve a problem? There is one thing, but throughout the semester, you're going to hear me asking this question: how many times is this loop executed? Because that's what is expensive. That is what one is aiming to minimize. Okay, how many operations does your code does? It becomes equivalent to how many times your loops are executed. All right, so to give you an example of that, some things. So you have seen 1,000 rectangles can be done fast, and the 100,000 can be done fast and stuff like this. But here, there are 3 lines of code here, or whatever, 3. Let's add them all up here. Forget this. 1, 2, 3, I don't know, 10 lines of code. Let's say I do this, 10 to the 1,000. I want 10 to the 1,000 rectangles. If I press enter and don't forcefully stop this program, when do you think this program will end? When it's going to end up and finish drawing 10 to the 1,000 rectangles? None of us would live to see the end of this program. 10 to the 10,000, well, it's probably, we can do the computation. It's probably 100 years, 1,000 years. You can do computations for that. Okay, so if you have 10, do I have time for this exercise? Or you can do this exercise by yourself, 10 to the 10,000. And let's say a computer can do 1,000,000 operations a second. Let's see how many seconds do we need. That's 1, 1, 2, 3, 1, 2, 3. Oh, because I'm doing English. Okay, so I should just remove some of these zeros. I can do this computation the other time. This is example of what happens if you're trying to do PEL numbers with the division. You're going to end up doing the real, but these dividing by 1,000,000 is just removal of zeros, so you can do it yourself. Anyway, so you can do it home. 10 to the 1,000 divided by 1,000,000, you get a number of seconds, convert that to minutes, convert minutes to hours, convert hours to days, convert days to years, and you're going to get about 1,000 years for this. Okay, so it's the loops that make your computations inefficient, and that's what computer science is about: finding solutions that do as few operations as possible. And that's why it's a science. That's what you're going to be studying throughout this program. And that's what distinguishes, again, I think I already mentioned this, what distinguishes a hacker from a super valuable programmer that the top companies are going to be fighting for. Okay. All right. So that was on the side, but you need to know how many times lines of code are executed, both for the efficiency and for your understanding of what your solution does. Okay, so the range function, let's go back to what we were doing. The range function produces sequences of numbers that you tell it, but it produces it on the fly, really, but that doesn't really matter. It's not important what it does. You really can imagine that it produces it all at once, and then it processes it one by one. Okay, that the loop is processing it one by one. So let's look at some examples of what go back to basics to understand this. Let's really, so as I was telling you that what gets stored in I is first element that of a sequence that range function produces, then the second element, and so on. So let's verify that what I was telling you is true, and it's easy to do. You just ask Python to tell me what is stored in I. Okay, so as I said, the range function in this case produces a sequence 0, 1, 2, and so on, up to 10. So the last one is 9. So if that's the case, every time you enter the loop, I will be assigned the next element of the sequence. So first 0, then 1, and so on. So it should print these numbers. Let's look at that. And indeed, it prints a sequence 0 to 9. It takes these elements one by one, prints them one by one, and then we print goodbye. Okay, so let's say that, oh, I may say, oh, wait a minute, I actually really would like to print 1 to 10, right? I don't want to start at 0. Let's say we want to solve that. I want to, put counting the way humans prefer. There's many ways to do this. Here's a simple one. I'm still going to use the old range function that produces sequence starting of 0, but every time I'm printing an element on the sequence, for example, 0, I'm not going to print 0, I'm going to print 0 plus 1. So I'm add 1 to every element of the sequence. So that's one way to solve that problem. Another one is not to touch that. So really, it's just to produce the sequence that I want. And what's the sequence that I want? Is the one that starts at 1 and goes to 10, including 10. So I'm going up to 11. So in that case, you can use this second form of range function when you give it two integers, a starting one and an ending one. So in that case, the sequence is really like this. We go up to 11, so the last should be 10. So let's verify that that really produces that. And we get that indeed it does. Okay, now this looks like some sort of counting. So usually in this class, I tell a student, imagine we want to run, blast the rocket into the space, and you always count there. 1, 2, 3, blast off into the space when you get to 10. So let me change this. But before I do, actually, let me show you something else, a third use. Okay, let's say that I ask you, so here we printed all the integers. We printed numbers from 1 to 10. Let's say I ask you, okay, I want you to print all the single-digit even numbers. So what are the single-digit even numbers? 2, for example, 4, for example, not 10, because it has 2 digits, right? So we want to do something. Okay, maybe I can keep this. All right. And then inside here, we know how to test if something is even. I can say if I remainder division with 2 is equal to 0, then the number is even. In that case, I print it. Otherwise, I don't print it. Okay, so you can say, oh, here it is. This one prints all the single-digit integers, even integer. Well, first of all, 10 is not one of them, so I really should go up to 10. Okay. Second of all, What about 0? 0 is a single digit even number. It's divisible by 2. Okay, so I should actually start at 0. All right. So here we have all the single digit even numbers. Is that true? I'll answer for yourself. Well, not, because, you know, -2, -4, and so on are also single digit even numbers. So in fact, we should start. So what is the smallest single digit even number? We should start with it, and it's -8. It's not -10, it has 2 digits, so it's -8. So we should go from -8. So here's the thing, I should go from -8 to 10, not including 10. So, and then I will really get all the, and I test for each of these numbers. Is it, I start with -8, there's no point starting -9, right? It's odd number, and -10 is already a 2-digit number. Start with -8 and go up to 10 and test which ones are even, and you print them. So here's a correct solution. But there is a different way to solve it that completely avoids doing these if statements. So, you know, in some ways, I'm reducing the number of operations I do. I don't even need to do the if statement. And it's that third form. I can just ask the range function to produce to me the sequence from -8 jumping to going up to 10. So I start with -8. If I add 2 instead of 1 to such a number, I'm going to get all the even single digit even numbers. So start at -8, go up to 10, and every time you're producing a new number, you add 2 to it. Okay, so -8 is first, so you print -8. -8 plus 2 is -6, so you print -6, and so on up to 10. So you can see that this solution 2 is producing all the single digit even numbers. Okay, just a moment. I need some liquid. Okay, so what I wanted is, okay, so these are some example of uses of all 3 forms. With a single integer, when you always start at 0, with 2 integers, where you start at a given integer, or with a 3 one, where you're given both the start and up to value and the skip that you are making. Okay, so let's go back to this Blastov thing. We want to send a rocket to space, and we want to count and then send it to space. And we said, okay, produce numbers 1 to 10, and then after 10, send the rocket to space. Okay, so we want to do a countdown. But then you should say, well, wait a minute, when you're sending a rocket, isn't it actually countdown, not count up? Isn't it 10, 9, 8, and so on? And then after 1, you blast the rocket into space. So let's actually write a countdown program, the one that counts down. Okay, so there is a way to do this like this. I mean, you just find a mathematical solution. Instead of starting at I, you can say, oh, I'm going to do 10. My first number is, I want to start with 10. My first number is 1. And so it's something like this. You can solve this mathematically. This would be a solution, right? So this is one way to do it. They use a bit of working out a little equation of that produces a countdown, but I'm actually trying to teach you what range function can do. So let's say that, you know, you want to keep an eye here. I'm really producing the numbers that are in the sequence that the range function produces. So what do I want? I want to start at 10. I want to go down to 1. Okay. But remember, second number is the one that you don't take the second number. You go as close up to it or down to it, if you like. All right, so we want 10 down to 0 and not including 0. But remember, the third number is actually a value that you're going to be either the value that you're going to be adding to create your sequence. So if I give it a negative number, when you add a negative number, the next number is going to be smaller. So in this case, we are starting with 1, going down to 0. And the way you're going to compute the next number is you're going to reduce the current number by 1. Okay, so let's see that that works. There you go. So now you see you have seen examples of various form of the range function. The last thing I would like to see, some of you may be tempted to test, since I told you and you have seen it. Let's go back to the simplest of example, that this produces a sequence 0 up to 10, and we verify it by printing. You may be tempted to do this and expect that this produces a sequence, but it doesn't. This is what it goes back to when I was saying that range function produces numbers on the fly. It never actually produces a whole sequence. It only produces one number at a time. And actually there is efficiency reason for that. Remember, you want to imagine I put 1,000,000, right? So it produces a sequence from 0 to 1,000,000. So there's a 1,000,000 number. If it produces really the whole sequence, you will need the space to store 1,000,000 numbers. There's complete waste for things like this, where all you need to know to produce the next number is what is current number. If current number is 100, then the next one is 101, if that third digit is not there. If the third digit is there, then the next number is 100 plus that third digit. If it was 3, the next number is 103. So range function produces numbers one by one from that sequence. So that's why you actually don't see a sequence here. It doesn't return to you the whole sequence, okay? Because if it produced the whole sequence, it would have to store it, and that would be a waste. In Python 2, it used to produce a sequence, but then the basically creator of Python realized that didn't make sense and changed it in Python 3. Okay, so this is the end of the lecture.